Hi everybody. Today we're going to be working with proofs with angles. We have lots of proofs to do, so let's jump right into the computer and get started. So we are proving angle pair relationships, all the relationships within angles. Let's start with our first theorem, Theorem 2.3. Make sure that you guys take notes on all of this, and you'll have to show me your notes at the end of the video. So Theorem 2.3. Right angle congruence theorem. All right angles are congruent. So if we have two angles that are apparently both right angles, both 90 degrees, then yes, in fact, they're both going to be congruent.
Okay, let's take a look at this problem. We got the given. Angle 1 and angle 2 are right angles. Obviously they're right angles. They both have the little red corner. We want to prove that angle 1 is congruent to angle 2. Common sense says that, but let's prove it. Let's prove that we are undeniable. Well, we first start with our little statements and reasons, as always. And the first thing I like to do is start with the given. Always start with the given. So, my given is the fact that angle 1 and angle 2 are right angles. They are right angles. Alright, number 2. Well, let's flow from the given here, and because angle 1 and angle 2 are right angles, I know that the measure of angle 1 equals 90 degrees. And the reason is the fact that it's the definition of a right angle. Simply enough. Okay? And 3. Let's say it again. Let's say we know angle 1's 90, angle 2 is also 90. So we can say the measure of angle 2 equals 90 degrees. And let's just say that's the def of right. And I'm going to use a little angles. Right angles. Cool. Alright, let's take a look at part number 4. Alright, I know because angle 1 equals 90, angle 2 equals 90. Oh, 90 and 90 both equal different things. I see some transitive. I see the transitive POE, and I'm going to then say that the measure of angle 1 equals the measure of angle 2. Alright, part 5. Part 5. Alright, well, the answer is actually not the measure, it's the fact that they're congruent. So then I'm going to say because the measures are equal, then I know that angle 1 is in fact congruent to angle 2. And that's the definition of congruence.
And for the next one,
thank you very much.
Theorem 2.4 is talking about the congruent supplements theorem. Supplementary, don't forget, is about 180 degrees. So let's read it. If two angles are supplementary or add to 180 degrees to the same angle or to congruent angles, then they are congruent. This is kind of hard to understand, so let's look at the picture. If we have a situation like this, where we have three angles here, and we know that angle 1 and 2 are supplementary, so that means that 1 plus 2 is going to equal 180 degrees. And then we also know that 2 and 3 are supplementary, therefore we know that 2, or angle 2, plus angle 3 also equals 180 degrees. We can't forget the little angle signs, little angle, little angle, little angle, little angle. So we know 1 to 2, 1 plus 2 is 180, 2 plus 3 is 180, then for sure we know that angle 1 is congruent to angle 3. If we have this situation, then we're going to have this situation. We can call it 2.5. This is the congruent supplements theorem. So this is complementary. Don't forget that that's going to add up to 90 degrees. Anyways, if two angles are complementary to the same angle or to congruent angles, then they are congruent. So we're dealing with complementary this time instead of supplementary. So the same idea, if we have this situation where we take angle 1 plus angle 2, but this time they add up to 90 degrees, and then 2 and 3 are also complementary, so angle 2 plus angle 3 also adds up to 93, then what do you think? Well, you're right. We know that then angle 1 is going to be congruent to angle 3. All right, cool. Okay, the recording on the last one was messed up, so I'm going to do a different recording type. Let's look at this problem, and we're going to start with the given, and we'll take a look here, and we're talking about supplements. We're going to prove that angle 1 is congruent to angle 3. Start out here with the statements, and we then start with the reasons. So number 1 is going to be, what is it? Number 1's always the given. So we're going to start with the given. So we're going to repeat angle 1 and angle 2 are supplements. And the second part is the second given. We know that angle 3 and angle 2 are also supplements. So if we know that they're both supplements, then what's special about supplements? Well, we know that supplements add up to 180 degrees. So we're going to say that the measure of angle 1 and the measure of angle 2 equals 180 degrees. And that's the definition of supplementary angles. 4. We also know that angle 3 and angle 2 are supplements. So the measure of angle 3 and the measure of angle 2 equals 180 degrees. Also the definition of supplementary angles. All right, so step 5. What do we know now? What do you notice? Uh-oh, I see 180 degrees equals that, 180 degrees equals that. What's special about that? It starts with a T. You should have seen the transitive theorem, or the transitive POE. So now we can say that angle 1 plus angle 2 equals angle 3 plus angle 2. All right, and that's going to be the transitive POE. Okay, now notice, what do we want to finish in the end? The end result is going to be angle 1's congruent to angle 3. Do you notice we can subtract out angle 2? So I can say angle 1 is congruent to angle 3. But we're not congruent yet. We just did the subtraction POE. So let's make this a little bit smaller, and now I can actually finish it, and I can say that angle 1 is congruent to angle 3 because of the definition of congruence. All right, now let's take a look at the linear pair postulate. That's saying if two angles form a linear pair, then they are supplementary. So they add up to 180 degrees. So if we have a situation like this, and these are obviously a linear pair, we can even draw an arrow here. They're a linear pair. Then I know that they're going to add up to 180 degrees. Simple as that. And for the last theorem, we know the vertical angles congruence theorem. Basically, that says that vertical angles are, in fact, congruent. So let's take a look what that means. If we have a situation like this, this means we have vertical angles here. 1 will be congruent to 3, and 2 will be congruent to 4. So if this situation, then we'll have angle 1 is congruent to angle 3, and angle 2 is congruent to 4. 1 to 3, 2 to 4. Let's look at this proof about vertical angles. We're going to prove about vertical angles. So we got to prove that angle 5 is congruent to angle 7 right there. So let's start out with our statements and reasons. Start out first with the given. Our given is the fact that angle 5 and angle 7 are, in fact, vertical angles. We want to prove that they're congruent. So step 2, well, what should we look at 5 and 6? They look like they're a linear pair. So we're going to say 5 and 6 are forming a linear pair. And we can just say that's the definition of a linear pair. All right, we can also see that, well, what are we seeing? Oh, erase that. And then let's take a look at 6 and 7. We can see that 6 and 7 also form a linear pair. Okay, that's the definition of it. Let's call it a LP. Okay. Step 4. Well, what do we know about linear pairs? Don't you remember that linear pair postulate said that if they're a linear pair, then they're supplementary and they add up to 180 degrees? So that means that we have angle 5 plus angle 6 is going to equal 180 degrees. That's the linear pair postulate. All right, we can do the same thing for part 5. We can say that 6 and 7 both add up to 180 degrees. That's the linear pair postulate again. So let's look at the next part. Well, do you notice it? Do you see it? It's transitive. We know that they both equal 180s, therefore angle 5 plus angle 6 is going to equal angle 6 plus angle 7. So there we go. And now do you notice that we have a 6 on both sides of the equation? Looks like we can subtract out a 6 from both sides. So we're going to get angle 5 equals angle 7 because of the subtraction POE. So, the last part, it has to be congruent. So we're going to have to say that angle 5 is congruent to angle 7 because of the definition of congruence. Same length, definitely congruent. All right, don't forget the measures. Also, this was one way to do it. Let's find another way to solve the same thing. All right, so let's start from the beginning. All right, well, we found out the linear pairs. And we know if things are linear pairs, then we know that they're supplements. So if they're linear pairs, they're supplementary. It's the linear pair postulate. So let's do that for both. Let's also say that 6 and 7 here are supplements because they're a linear pair. That's the linear pair postulate. Now, don't you remember from before about the congruent supplements theorem? Because if we have this, then we have that. Therefore, if we have this situation, we know that angle 5 is congruent to angle 7 by congruent supplements theorem. Woo! There's the second way. Okay, let's just look at one more proof. We know that this hexagon is regular, and we want to prove that angle 1 is equal plus angle 2 equals 180. Start with the given. We know that the hexagon is really just like a sixagon. So let's say that the sixagon is regular. If we know it's regular, then all the angles are going to be congruent. So let's name some angles that we don't know yet. So now I can say that actually angle 3 is congruent to angle 4 by definition of regular polygons. All right, next, what can I see in the picture there? Well, I can see that we have a linear pair with 4 and 2. So I know that angle 2 plus angle 4 is going to equal 180 degrees. That's a linear pair postulate. Okay, next, what else do we see in the diagram? 1 and 3, they look like vertical angles, so they're going to be congruent. So angle 1 is congruent to angle 3 by vertical angles. Now let's take a look at part 5. Well, what do we know with angle 1 and angle 3 and angle 3 and angle 4 and all these other things? Well, I see a transitive. Do you see the transitive? Take a look at the 3 and the 4 and the 1. So we have angle 1 is going to be congruent to angle 4 by the transitive theorem. Do you see how the 3 there and the 3 and the 4 and the 1? Yep, that's it. So part 5. Now, what are we trying to prove? We want to prove that angle 1 plus angle 2 equals 180. So do you see the substitution? There's substitution. Angle 2 plus angle 1 equals 180 degrees by substitution, POE. And as you can see, our part 5 looks exactly what we're trying to prove. Now that we've had to the end, now we're at the end of the video, I want you to come see me and show me your notes. Show me that you wrote stuff. I want you to make more proof ammunition from what we just learned. Because we made it before, I want you to make more proof ammunition. Then I'd like you to also do page 128, numbers 12, 17, 18, 19, 20, 21. Lastly, continue the proof packet. We have all these proofs to do. 36, 38, 39, 42, 43, 44, and 47. Thank you very much.